Today, we are going to continue with graphing rational functions. You'll notice it says here, graph general rational functions. So, we're going to review what we talked about yesterday. A rational function is a function that has the form of f of x equals p of x over q of x. Now, I've added some to it here. And what this means here, I've got a sub m x raised to the m plus a sub m minus 1 x to the m minus 1 plus dot 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 plus a sub 1x plus a sub 0. Now that's the top of my function. All that means is this is a polynomial. M is the degree of my polynomial that's on the top of my equation. The a sub m is simply the number multiplied by that term, the coefficient of that term. A sub m minus 1 is just the coefficient of the next term, and so on. So this is just putting your polynomial in standard form where your highest exponent comes first and your lowest exponent or your constant comes last. The same thing goes to the denominator. The b sub n, the b sub n minus 1, those are coefficients of each term. The n is the degree of the polynomial in the denominator. So we'll look at some numerical examples here in just a minute. Now there are three things we want to consider when we are graphing these rational functions. The first thing we're going to do is we're going to find the x-intercepts of our function. We do that by looking at the numerator. Wherever the numerator, our p of x, is 0, that's going to be a 0 of our function, or where it crosses the x-axis. When y is 0, it crosses the x-axis. Okay, the second thing we're going to be looking for are vertical asymptotes. And we find that by looking at the denominator on the bottom of q of x, and we find all the zeros of that polynomial. And we've been doing this for some time. You guys know how to do this part. Okay. The third part is where it gets a little bit tricky. We've got the horizontal asymptote has three different possibilities. First, if the m is less than n. Okay, so let's look at what that means. That means that the degree of the polynomial on the top of the function is less than the degree of the polynomial on the bottom of the function. Then if that happens, then y equals 0 is the horizontal asymptote. If m equals n, if the degree of the top and bottom polynomials, the numerator and the denominator, are the same, then I take the coefficient of the leading coefficient of the top polynomial divided by the leading coefficient of the bottom polynomial, and y equals that number, that ratio, a sub m over b sub n, and that will be my horizontal asymptote. Now, if it happens, the C here, that the degree of the top polynomial is more than the degree of the bottom polynomial, then there will be no horizontal asymptote. So those are the things that we're going to look at in graphing these. So let's try, we're going to try three graphs. So we are going to move this forward here. We are going to graph y equals 6 over x squared plus 1. Okay, so the first thing I'm going to notice is, number 1, I want to see, is there going to be an x-intercept? So to check to see if there's going to be an x-intercept, I look at the numerator. I look at the 6. Can 6 ever be equal to 0? And of course the answer to that is no. So there is no x-intercept. the x-axis. Okay, second, I'm going to look at my vertical asymptotes, see if there's any of those. So I take my denominator down here, and I say x squared plus 1 equals 0. Well, let's see. I get x squared equals negative 1, and that can't happen. So, since that can't happen, then I say there is no vertical asymptote. Okay? So I haven't learned much about my graph so far. Now we're going to find horizontal asymptotes. Now, this is the one that's got the 3 parts to it. So let's just make a quick check back in our other slide. When m is less than n, that's the one we've got right here. When m is less than n, because the degree of the top polynomial in this case is 0, the degree of the bottom polynomial is 2, then I know that y equals 0 is my horizontal asymptote. So you look here, see, I have 6, so there's no x term here, so it would be the same as saying x to the 0. So its degree is 0. So since 0 is less than 2, and I say y equals 0 is my horizontal asymptote. So I got my x-axis as a horizontal asymptote. Now I put in here to write the domain and range. We're going to look at the domain, and we'll come back to look at the range in a minute. But the domain, well, I don't have any place that this function is not defined. So the domain is going to be all real numbers. And we'll come back to the range in just a minute. So let's plot some points here. We know it's not going to cross the x-axis. So let's look at 0. If I put a 0 into my function, 6 over 0 plus 1 gives me 6. So I know I have the point 0, 6. Okay? Now, let's move away from that and see what happens. So let's go 1. When x equals 1, I've got 6 over 1 plus 1. 6 over 2 gives me 3. So I have the point 1, 3. Well, let's see what looks like on the other side of 0. Let's do a negative 1. Well, negative 1 squared is 1, so that's going to be 6 over 2, which is 3 again. Okay, it looks like maybe I'm going to get some symmetry here. Look at the x squared, that kind of makes sense. Let's go one more. Let's look at what happens when I have 2. 6 over 2 squared, let's see, 2 squared is 4 plus 1 is 5. That's 6/5 or 1 1/5. And because it's x squared, I'm going to get the same on the other side. So 1 1/5 will be around here. Now, it should be enough here to kind of get a shape, because I know that the asymptote of the x-axis has to look something like that. Now, let's go back to the range. You look and see, okay, what was the biggest y value that I could have? Well, 6 is the biggest it gets, and then it goes down from there. And then you look at the littlest could be, since y is an asymptote, it has to be greater than 0, but it can't be equal to 0. So I say 0 is less than y, which is less than or equal to 6, and that gives me my range. And we have our first graph. Let's look at second. Let's look at y equals 2x squared over x squared minus 9. Now notice that I have an x squared in the top and x squared in the bottom, so my degree of my on the top is equal to the degree on the bottom, which we'll get to in just a minute when we talk about the or the horizontal asymptote. Okay, so now I have the x-intercept. So I say 2x squared equals 0. So I take my numerator, set it equal to 0. So that tells me that x is 0. So I have our x, that's my x-intercept. So I have the point 0, 0 on my graph. Okay, well, that's interesting. It goes through the origin. Okay, so then I'm going to find vertical asymptote. So I look at the denominator, that's x squared minus 9. And I set that equal to 0. Well, that factors of x plus 3 times x minus 3 equals 0. So x equals negative 3 or x equals 3, those are my vertical asymptotes. And I'm going to go ahead and draw those with dotted lines. And I have my two vertical asymptotes. So we will want to label these. Might have to move that if my points get moving. Okay, now we're going to find any horizontal asymptotes. So let's go back and see what happens when m equals n. So now we're on b here. My degree of my top function equals the degree of my bottom function. Say y equals a sub n over b sub n. A sub m over b sub n. That's my leading coefficient. So the leading coefficient on the top is 2. So I say y equals 2 over the leading coefficient on the denominator is 1. So my asymptote, my horizontal asymptote is y equals 2. So let's go ahead and draw that one on our graph. Label it so we keep track of what we got here. Okay, now let's look at the domain here. The domain is going to be, well, let's see, it's going to be all real numbers such that x is not equal to negative 3 or 3. So that's my domain. That divides my graph into 3 branches, and I'm going to want to plot some points in each branch. So let's look at the left branch first. So let's look at, say, negative 4 and negative 5, because I need to be to the left negative 3. So if I put a negative 4 into my function, I've got, see, 2 times negative 4. Well, negative 4 squared is 16 times 2 gives me 32 over 16 minus 9, which is 7. So that's going to be 4 and 4/7. Okay, so let's try negative 5. So I've got negative 5 squared is 25 times 2 is 50 over, okay, 25 minus 9 on the bottom is 16. So that would be 25 over 8, which gives me 3 and 1/8. Let's plot those two. Negative 4, more than 4, negative 5, more than 3. Okay, I know where my asymptotes are, so that's going to give me the shape of that branch. Let's do the right-hand branch next, because since my values are squared, my x's are squared, my y values are going to be the same. So on Okay, so now let's look at the one in the middle. Now I know that I've got 0, 0 on my graph. So let's do a couple more in the middle there. So let's go to -1 and 1. And you know, because x is squared on both top and bottom, it's going to be the same value for those. So -1 squared is 1 times 2 is 2 over 1 minus 9, so -8, so it's going to be -1/4, and it'll be that for -1/4. Okay, -1, -1/4, and we can see that the movement is going to be down, and I'm going to be approaching this asymptote. I'm going to break that one. We have that basic shape. Now let's look back at the y values, the domain, or the range. So for our range here, we know that y has to be greater than 2, or the highest on the bottom there is 0, 0, so y is less than or equal to 0. That would be our range for that. So there's graph number 2. And we have one more. Okay, the last one, we're going to look at when our x squared is on the top and I have an x on the bottom. So I have y equals x squared plus 3x minus 4 over x minus 2. So my numerator, or my exponent on the top is greater than the exponent on the bottom. My degree on the top is greater than the degree on the bottom. So if you look back here, you'll notice that's going to give me no horizontal asymptote. So let's find the x-intercept. So we set the top equal to 0. So I've got x squared plus 3x minus 4 equals 0. So I can factor that. I've got x plus 4 times x minus 1 equals 0. So I get x equals -4, or x equals 1 for my two x-intercepts. So I've got this point and this point on my graph. So finding vertical asymptotes, I say the denominator is equal to 0. So that gives me that x equals 2. It's a vertical asymptote. Let's draw that one. Now, nope, not there. Moving over, that's -2. So there's x equals 2. Well, that's kind of interesting. There's no real symmetry showing up just yet. Usually these have some kind of symmetry. Now remember, there's no horizontal asymptote. So let's look at our domain here. Our domain is going to be all real numbers such that x is not equal to 2. Now, you'll notice I said plot 4 points at each branch. Sometimes you kind of have to play with this to get enough points to actually see what's going on. Now, I already have that x equals 1 and x equals -4 are in my left branch, so I'm certainly going to use those. So let's start at 1. Let's do 0, and let's do 4. And we'll kind of look at those three and see if we need to do another one. Let's see, when x is 1, I've got 1 plus 3 is 4 minus 4, that's 0. We already knew that. When x is 4, that's also 0. Okay, when x is 0, I get -4 over -2, so that's going to be 2. So I've got the point 0, 2. So that's going up. Let's try another one in there. Let's let's try 2. 1, 0, oh, no, not 2, negative 1. Where I'm going the wrong direction. Let's do negative 1. Okay? So, when I have x is negative 1, and I've got 1 minus 3 minus 4. Well, 1 and 3 minus 4 is minus 7, plus 1 is negative 6 over negative 3. So that's going to be a positive 2. Okay? 0, 2, negative 4, 0, negative 1, 2. Okay, so it's not real clear. I know that this side must be doing this. Let's get one more that's further out than negative 4. So let's say negative 5. If I put a negative 5, I get 25 minus 15 minus 4 on the top. So 25 minus 19 gives me 6. And negative 5 minus 2 is negative 7. Negative 6 sevenths. Okay, so now that's going to start giving me an idea of what's going on. So I've got negative 5, negative 6 sevenths. Okay, so I can kind of see a shape taking place here. This will look something like that. Now let's look on the other side. Okay, well, let's see. I know it had to do 2, so let's do 3. Well, let's see. 3 squared is 9, plus 9 minus 4 over 3 minus 2 is going to be 14 over 1. So 18 minus 4 is 14. Wow. Okay. See? 14. That's off of here. Okay. Let's see what happens with 4. Okay, so I've got 4 squared, which is 16, plus 12 minus 4 over x minus 2, so 4 minus 2 is 20. Should have done this before I start drawing my graph. 28 minus 4 is 24 over 2, which is 12. Okay. 4, 12. Okay. Now let's keep going. Let's go 5. Now, pattern that I had before follows, looks to me like maybe it'll be 14 again, so let's try that. So I get 25 plus 3 times 5 is 15 minus 4 over 5 minus 2. Now let's see, 25 and 15 is 40, minus 4 is 36 over 3. Well, not quite, it's 30. Okay, but it is starting to come back, go back up again. 30. Okay, let's do one more. That's a little further out. Let's go ahead and just do 6. See where it goes from here. So I've got 36 plus 18 minus 4 over 6 minus 2 is 4. So we get the graph. Now, what you might want to do is use your graphing calculator to check, because it doesn't look like we've probably found the exact max and the exact min. So we're going to use our calculator to calculate the minimum and the maximum. When you do that, I get my minimum at 4.4, 11.9, and my maximum I set a left bound, right bound at negative -0.4 and 2.1. So when I make my range, I'm going to be y greater than or equal to 11.9 and y less than or equal to 2.1. So that gets a little bit trickier there. And we have picture arrows. Your asymptote should be labeled. Let's do that. Like 2 and your t-tables, and we have that.